Hi, it's Dr. Robin. Today I'm going to talk to you about how to succeed at organic chemistry. So the reason I'm making this video is because I have a lot of students who take general chemistry from me and they're doing it as a prerequisite for taking organic chemistry. Some of them may be going to med school. Some of them want to do grad school in biology or environmental science or something like that. And one thing that I hear over and over again is that they're scared. Organic chemistry, OChem as some people call it, has a reputation as a weed out class or just as, something tough. And I think there are two reasons for this. The first is organic chemistry is not like other branches of chemistry. A lot of chemistry is mathematical. This is definitely true of general chemistry. You'll see that there's an awful lot of math in almost everything that we do. If you take chem, that's basically lots of math with some chemistry thrown on top. If you take analytical chemistry, it's a different sort of math. Like you're not doing the multivariable calculus that you get in chem, but it's still mathy. And I should know because I also teach analytical chemistry. There are a lot of people who say, I'm really not very good at general chemistry. I'm barely making it through the class. How can I possibly do well in organic? And honestly, the tools that you need to survive in organic chemistry are, for the most part, very different tools than what you need to succeed at general chemistry. The flip side of that is people who are good at Gen Chem are not necessarily always good at organic chemistry, because what you need there is like I said, a sort of different set of tools. And by sort of, I mean not math. You're going to need some spatial reckoning, like how do things fit together in 3D? And we'll talk a bit more about what to do about that in a little bit. But there is one tool, and that is my number one secret of how to succeed. There is one tool that is good in general chemistry that is also good in organic chemistry. And so we'll get to that. That's my number 3 tip. When my students come to me and ask me, how can I prepare for organic chemistry? I tell them 3 things. The first 2 things kind of go together. And if I want to say what those 2 things have in common, basically, there are a certain set of tools that you need to survive organic that take a lot of practice to get used to. And when you study organic in the classroom, you usually get maybe 1 or 2 lectures on this, and then they move on. And they're like, well, I lectured on that. They should know it. But you need a lot of time to practice these. And my first 2 suggestions are to take skills that you would be learning early in organic chemistry and practice them before the class actually starts. So the first thing you should learn is organic nomenclature. Again, I don't think I got more than 2 lectures on this when I took organic chemistry. And then if you haven't picked it up by the end of those 2 lectures, the professor is just going to assume that you know organic nomenclature, and the professor will keep using that organic nomenclature as if you know it and are fluent in it, because it is basically a language. It's the IUPAC naming scheme. So the professor will be lecturing and they'll say, for example, 3-methyl 2-pentanone, and you'll be like, oh, wait a second. Okay, so 3-methyl, so penta, that's 5, and then the methyl group on the 3rd, so we have to put a CH3 on the 3rd group, on the 3rd carbon, and then there's a ketone, right? So you go through all this thing and you're like, okay, now I know what this is, and then you're like, and what are we saying about this thing? And well, the professor's already 2 or 3 miles down the road, because while you were stopping to think about what does this thing look like, the professor just kept talking. And so if you know the naming schemes, then these things make sense to you. Okay, so the second thing is similar, but not quite the same, and that is, what do things look like in 3 dimensions? Now, you got a taste of this in general chemistry when you did your molecular geometry unit. But the molecular geometry that at least I talk about in general chemistry is not really the molecular geometry of super large molecules. We get into a few different things that maybe like have 3 carbons or something. That's probably about as big as we go. And in organic, you're going to be dealing with much, much larger molecules. Clearly, you need to understand how large molecules look in space. And the way you're going to do this is you're going to get yourself a molecular model set. The best molecular model set that I have found is the MollyMod set. And you can buy them on Amazon, but honestly, get them on eBay. Or definitely buy them used, because there are lots of people who buy them because it's required for their organic class, and then they sell them again, and you don't want to pay full price for these things. They're expensive. But I've gotten them off eBay for like 20 bucks, which is very reasonable. So if you have your MollyMod set, then try building large molecules. So when you're going through, before organic starts, when you're going through and doing the naming schemes, actually build those molecules that you're naming with your MollyMod set. My third and final tip is the one that also applies to general chemistry, and that is stop memorizing. When people say they're struggling with organic chemistry, the reason almost always is there's too much stuff to memorize. They can't keep up. Guess what? You should not have to memorize. If you have a good professor, and I think the odds are only about 5 or 10% that you do, if you have a good organic professor, they will teach you principles and then give you a bunch of different examples. Instead of saying, here is this reaction, this is what happens. Here is that reaction, this is what happens. Here is that reaction, this is what happens. So the way organic should be taught is by teaching principles and saying, look, here's this reaction, the next reaction in the book. Let's talk about how this applies to the principles we've been covering so far. Now, to be clear, I've never taught organic, and I hope I never will, because I don't particularly like organic. But my dad taught organic for 32 years, I want to say, before he retired. And so I think he knows a thing or two. Actually, I got most of these tips from him, so kudos, Dad. So let me give you an example. You could have a reaction where they're talking about how carboxylic acids react. And then a couple of days later, you might have a reaction where there's a ketone reacting with the same sort of thing that the carboxylic acid was reacting with. Well, both of these things have that double bonded oxygen, right? And really, that's where you see a lot of the stuff happening, is with that carbon-oxygen pairing. So even though they have slightly different outcomes, it's based on the same principle. And the principle is electronegativity differences, right? Which is one of the #1 things you want to look for in organic chemistry. So if you look and you try and find patterns, you're going to see things like, okay, electronegativity differences, steric hindrance, all those sorts of things. Make a list of principles that affect organic reactions. And then every time you encounter a new reaction mechanism, see if it fits the rules, because it usually does. Every once in a while, you'll add a new rule, but most of these things are just the same principles over and over and over again. Again, I prefer not to work with organic chemistry, but it's not that I couldn't, because I got straight A's in organic chemistry and pretty much aced all the tests, basically because I followed these tips that my dad gave me before I started organic. So those are my 3 principles for succeeding at organic chemistry. I hope this was helpful. Subscribe if you want more tips. Ask me questions that you want me to answer, and I will see you again soon.